What's up, YouTube? It's Mr. Clever back with another quarantine math video. And today we're going to be talking about lines of best fit and linear regression. Now, don't let regression intimidate you. I know that's a big word, but we will discuss it. And hopefully by the end of this video, you will know what you're talking about. Okay, so first I have a warm up, getting you familiar with scatter plots, remembering how scatter plots work, how to create scatter plots. So I have a problem here for you. Mr. Oshiro wants to find out if there is a correlation, there's a keyword, between the number of hours his students spend each night doing homework and the number of hours they spend playing video games. He surveyed 7 of his students, and the results are in this table below. So I want you to plot these results on a grid and create a scatter plot. I have a grid on the screen. Feel free to take a screenshot and print that out, or just grab some scratch paper, draw a grid, and then create your scatter plot that way. And then I want you to note if there is a correlation. And if you remember, a correlation simply means, do the data points trend upward, downward, or not at all? We'll talk a little bit more about that today. And finally, write down anything else that's kind of odd, that's peculiar, that you may notice about these data points. So pause this video, go ahead and do those things, and then come back and we will review. All right, hopefully you were able to make a scatter plot. And now we're going to go over it, create it on here, and see how well yours matches. So Stacy, the first student, spends 2 hours each night doing homework. So we look at the horizontal axis, because that's the axis that represents the number of hours doing homework. And we go over to 2, and Stacy also plays 1 hour of video games each night. So we go up the vertical axis to 1, like we see over there, and that's where our first data point is going to go. Similarly, we can look at Sean. He spent a half an hour each night doing homework and 2.5 hours playing video games. There's his point. Madeline spent 3.5 hours doing both. So we go over on the horizontal axis to 3.5 and up on the vertical axis to 3.5, and there's her point. And if we do that for the rest of the students, we get a scatter plot that looks like this. So now my second question to you was, is there a correlation to this data? So what did you say? I think there is a correlation, and it is a negative correlation. If you remember, a negative correlation means that as the horizontal values are increasing, the vertical values are decreasing. So if we think about this in terms of graphing linear equations, this line, if you could imagine a line here, would have a negative slope. On the other hand, a positive correlation would mean that vertical values are increasing as horizontal values are increasing. So the line, if you imagine the trend where the points are headed, is going to have a positive slope. But did any of you notice anything peculiar about any of these data points? The thing I noticed was that Madeline's data point up here doesn't really follow this negative trend. She's just kind of doing her own thing. She's playing 3.5 hours each night of video games and doing 3.5 hours of homework each night. That's a little extreme. Obviously, she is not following that trend. She is what we would call an outlier, and we're going to talk about that and how that relates to lines of best fit here coming up. Now what I want you guys to do is open up a new tab and go to www.nctm.org. That is nctm.org. I will pull it up myself here. If you're having trouble, I will have a link in the description of where exactly we need to go. Once you're at nctm.org, that's literally all you have to type in. Click on the search bar and type in line of best fit, which is what we're going to be talking about. And it'll take a moment or two, and it will bring up a list of results. And for me, it's going to be this second link, but you're going to want to click on the one that says line of best fit illuminations. You want the one that says illuminations. On this website, there are a lot of these illuminations that NCTM calls it, but basically little online applets that we can play with. All right, I'm going to move my screen. Okay, now what I want you guys to do, we have a graph, we have some other buttons, some other mysterious things, we have a table. What I want you to do, and I'll throw it up on the screen here in a little bit, but I want you to put the table that Mr. Oshiro's data with the students, put those values, the X would be the horizontal axis and the Y would be the vertical axis, put those numbers in this table, and then we were going to analyze them. Once you put them in, they should show up on the graph. So go ahead and do that, come back, and then we'll talk some more about it. All right, so I have my data in. It should look exactly like it was on the PowerPoint slides that we saw. It's a little bit zoomed out. So what we can do, we can click this magnifying glass down here with the plus sign, and that will allow us to zoom in a little bit more. Or we can click the magnifying glass down here with this little box, and if we click on that, that will bring up a window that has our data points and only our data points that we can see, which is great. It's awesome to analyze it. All right, so the first thing we're going to look at, and if you haven't done it already, go ahead and click on this box over here that says Show Line of Best Fit. We click on that, and this mysterious green line appears. And as you probably guessed by the little this little line of text here, that this line is a line of best fit, which is what we're going to be talking about. So take a minute, think. Just based on the name, what do you think the purpose of the line of best fit is? What does it do? What does it represent? So take a minute and we'll talk about it. All right, so line of best fit. The line of best fit is essentially the line that best fits or best represents our data points. And with this line, if we zoom out of here, with this line, we can use this line to predict values that we don't even have. So maybe some student played, it looks like if the student did 8 hours of homework, then they probably played 0 hours of video games each night. So it's a very helpful tool, for analyzing data. And if you look over here on the left where we clicked on the checkbox for the show line of best fit, there are two equations in green. One says r equals negative 0.36. We're going to talk about that, but not yet. And the other you may recognize as a linear equation. It has a slope, a rate of change of negative 0.34, and a y-intercept of 2.59. So if we look, let me zoom back in. Our line of best fit is intercepting the vertical, the y-axis, when y is 2.59. And it looks like a little bit above 2.5, so yeah, that's probably right. And it has a negative slope, right, because it has a negative correlation. Now, we talked a little bit about Madeline's point and how it's an outlier. And if you notice, her point is the farthest away from our line of best fit. These lines beneath the line are relatively far away compared to these points, but Madeline's is definitely the farthest away. And this makes sense, right? The line of best fit is supposed to approximate or represent the bulk of the data. And because Madeline is the only point that deviates from this negative trend, this negative correlation, it makes sense that she's going to be the farthest away from the line. However, I'm curious, what will happen? What do you think will happen if I would get rid of Madeline's point? If we eliminated that, how would the line of best fit change? Take a moment, think about it, and then let's try it. Okay, so to remove Madeline's point, we go down below the grid and we click on this X button. And then we can click on Madeline's point and it will go away. So let's see if your guess was right. And look at that. The line of best fit does change and it gets steeper. If you notice, the slope got steeper, the line got steeper, and the points, all of the points look closer to the line. These points that were farther away are now closer because the line tilted down towards them. Because without this point up here of Madeline's, this line is able to better represent the rest of the data. So that's an important note when you're analyzing data, that outliers can kind of skew the trend, the correlation of your data. Now let's look at this R value over here to the left. Haven't talked about that yet, but it is a very, very important point. So if we scroll down below the applet, below instructions, to this exploration part. We're not going to do this in this video, but it is great. It is great practice. Feel free to do it. Very similar to what we're doing with Mr. Oshiro's data. But if we read this little blurb here that I have highlighted, it says check the show line of best fit box, which we did, to see a linear approximation of the data. So the line of best fit, again, it approximates the data with a linear equation. Here we go. The correlation coefficient, R, so this guy up here, R, is called a correlation coefficient, indicates how well the line approximates the data. If the absolute value of R, so right, R can be positive or negative, and in our case, right, it's actually negative because we have a negative correlation. If the absolute value of R is equal to 1, the line is a perfect fit to the data. If the absolute value of R is equal to 0, the line does not fit the data at all. And as a general rule, the closer R is, the absolute value of R is to 1, the better the fit. So if we look at our R value, it is currently negative 0.89. That's without Madeline's point. And that is relatively close to -1. So again, we're taking the absolute value. So if we take the absolute value of R, we're taking the absolute value of negative 0.89, which is positive 0.89, which is pretty close to 1. So that means this line is what? Is it a good fit? Is it an okay fit? Or is it a bad fit? This line is definitely a good fit based on the correlation, or excuse me, the correlation coefficient. Now let's add Madeline's point back in to our data set. So I add her point, and note, watch what happens to the R. Boom, negative 0.36. It goes down by almost over 0.5 actually. So this line right here, the absolute value of R for that line is closer to 0 than it is to 1, which means this line doesn't approximate the data very well. There's really not a strong correlation. You'll hear those words, strong and weak correlation. That just refers to how close this R is to 1. So in this case, this line represents a weak correlation of the data, and without Madeline's point, this is a strong correlation, right? The points are really, really tight, close to the line. All right, now let's add Madeline's point back in again, and we will have our flatter line. Now let's see what happens when we add more points around Madeline's point. So take a minute, put 3, 4, 5 points around Madeline, and take note of what happens to our slope, our equation, the slope in our equation, and what happens to our correlation coefficient. Okay, I probably should have mentioned this before you tried that, but in order to add points without having to type in exact coordinates, just click on the grid. Make sure you don't have any buttons down here selected, and then just click anywhere, and I will add, see, whoops, I didn't mean to move her point. Move it back, right there, and I'll add 4 more points. And look at this, our line of best fit no longer has a negative slope, but it has a positive slope. And our correlation coefficient is very, 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 very small, very close to 0. And that makes sense, right? Because our line of best fit is nearly flat. So by adding more points above the line near Madeline, those points kind of pulled our line of best fit upward and actually gave it a positive slope. All right, so now what we're going to do, we're going to get rid of everything. So I already did that, but an easy way to do it, you have this reset button up here in the top right, so just click it, and that will get rid of all of our data points, our line of best fit, and everything. So we're done with Mr. Oshiro's data, and we're just going to play around a little bit. So now what I want you to do, add 5 points anywhere on your grid. You could even zoom out if you want to, zoom in, whatever you wish to do, drag it around if you choose to do so, and add 5 points anywhere, and then we're going to analyze it. All right, so I have my 5 points on here. Your 5 points, I'm sure, look different than mine. Make sure you don't try to copy mine. It would be boring if everyone just had the same points on their graph. And now what we're going to do is we're going to click on Show Guess. Do not click on Show Line of Best Fit, okay? And we're going to try to figure out how we can create a line of best fit for our data points, because in real life, we're not always going to have a button that just gives us the line of best fit. So I have my data points here, and it looks like they kind of have maybe a weaker correlation, right? Because when we were looking at Mr. Oshiro's data, the stronger correlation was when the points were really close together, and these points are kind of spread out. So when I click on Show Guess, it gives me a line with 2 draggable purple points, and from that, I can try to make a guess of what my line of best fit looks like. And over here underneath the checkbox, it has the linear equation giving the slope and the y-intercept, and it even changes as you change the line. So I'm going to kind of estimate where my line of best fit should go by just dragging these 2 points. And you should be doing the same. And as a general rule, you kind of want the same amount of points on one side of the line as there are on the other side. Now, of course, we only have 5 points, so there's not going to be an even number on both sides, but you don't want something that looks like this. Obviously, there's way more points on one side than there is on the other. So I'm going to make my guess, and once you have a guess that you're happy with and that you're that's finalized, oops, didn't mean to add a new point. Go ahead and click on Show Line of Best Fit and see how close you were. I was relatively close, not bad, not bad. And it looks like the way let's see if I can move. Let me get rid of my guess here since we have the right thing. Okay, and it looks like my data points have a relatively weak correlation, right? It's the R, the correlation coefficient, is closer to 0 than it is to 1. And my slope is 0.38, so it does have a slight positive correlation. Maybe your points have a strong negative correlation, maybe they have no correlation. And let's see, I'm curious what happens if I get rid of some of my points, see how it changes. Oh yeah, so as you get points, as you get rid of points and as you add points, your line of best fit is constantly changing, right? Because it's trying to best fit the data set. I hope this was helpful. Play around with this applet some more. There is this exploration activity down below here with basketball players. Feel free, play around with that. Very similar to what we just went through. And yeah, I'll see you guys next time.